Let's take a look at economic exposure. Now, changes in exchange rates can affect firms that are directly engaged in international trade, as you obviously would expect. But they can also affect purely domestic firms. If the domestic firm's products compete with imported goods, then their competitive position is affected by the strength or weakness of the local currency. So that is going to affect them regardless of where they produce the product or where they sell it. So let's consider a U.S. bicycle manufacturer who sources, produces, and sells only in the U.S. Since the firm's product competes against imported bicycles, it's subject to foreign exchange exposure. Keep in mind that their customers are comparing the cost and the features of the domestic bicycle against Japanese, British, and Italian bicycles, etc. A stronger dollar makes U.S. bicycles more expensive in the rest of the world, and foreign bicycles less expensive in the U.S. So a strong dollar might encourage people in the U.S. to buy a bicycle from Japan or from Italy. Now, exchange rate risk is applied to the firm's competitive position. And we want to keep in mind that any anticipated changes in the exchange rates would already have been discounted and reflected in the firm's value. So economic exposure can be defined as the extent to which the value of the firm would be affected by unanticipated changes in exchange rates. How do you measure exchange rate exposure? Well, many of you may be familiar with the concept of beta. Beta measures the risk of a firm's stock returns relative to some market index like the S&P 500. So you would take the returns for, say, Microsoft and regress them against the returns of the S&P 500, and the slope term beta would be that measure of risk. We can create a similar measure for industries by regressing the industry's portfolio return against the rate of change in the dollar exchange rate index. And we're going to refer to this as the Forex beta. Forex is the term we use for foreign exchange. And in the next slide, you'll see that an asterisk marks some of the betas, and that's where they are significant at the 10% level. So let's take a look at this. All right, here we have a column of market betas, and here we have a column of Forex betas. Now, hopefully I looked this up correctly, but I believe the market beta ranges from 0.310 to 1.613. So all positive. That means that when the market goes up, you expect the returns in that industry to go up. The Forex beta range is different. It goes from minus 1.272 to 1.831. So that indicates that when, for example, we have a positive beta, that indicates that the stock returns tend to move up as the dollar appreciates. Negative means that the stock returns tend to move down as the dollar appreciates. So you can see there are quite a few negative ones here. Not all of these are significant, but some of them are. We have some positive significant, negative significant, negative significant. So you can see that, you know, it's a lot less obvious, the relationship between exchange rate exposure and different industries as it is from market risk. So how do we measure economic exposure? Economic exposure is the sensitivity of the future home currency value of the firm's assets and liabilities and the firm's operating cash flow to random changes in exchange rate. So there are some different statistical measurements. We could measure the sensitivity of the future home currency values of the firm's assets and liabilities to random changes in exchange rates. We could also measure the sensitivity of the firm's operating cash flows to random changes in exchange rates. One way to do this is we can run the following regression. So here we're going to have the dollar value of a British asset against the exchange rate. And P is the dollar value of the British asset. A is going to be the intercept term in our regression. B is the sensitivity. It's the slope or the sensitivity of the dollar value of the asset, P, to the exchange rate, S. And S is the exchange rate, that is dollars per pound. When you're computing a regression, you can use a statistical program. Excel does it, and there are numerous regression analysis programs that compute slope coefficients. You can also compute it simply by computing the covariance between P and S, right? The dollar price of the British asset and the exchange rate divided by the variance of the exchange rate. So this is exactly how the regression package computes it. So you'll get the same answer. Let's take a look at a couple of examples here. So case 1, so we have 3 states of the world, and they all have the same probability. And the exchange rate, let's say, in these different states of the world can be $1.40, $1.40 per pound, $1.50 per pound, or $1.60 per pound. And the price in pounds can go from $9.80 to $1,000 to $1,070. And you get the price in US dollars by multiplying these two together, the British price times the exchange rate. And you can see you have different prices. If you run that regression or compute the covariance and variance, you'll get that B is 1,700 pounds. So that means that there's some risk here. There's exposure. There's a positive relationship between the local currency price, P star, and the dollar price of the pound, right? So as this goes up, this goes up. And it turns out here that an appreciation of the pound is associated with a rising price in pounds. Because the foreign price of the asset is random, we cannot eliminate all the risk by hedging with a forward contract. Okay, so we can eliminate some of it, and we'll take a look at that in a moment. Case 2. Here we have the case where, again, same probabilities, same future spot exchange rates, but here we have it a negative relationship between the pound price and the exchange rate. As the value of the pound rises, okay, the price here in pounds goes down. And this is a contrived example, but it's worked out so that the price in US dollars, this times this, turns out to be 1,400 regardless of the state of the world. And again, if you run the regression, you'll find that B equals 0. Right? We just mentioned there's a negative relationship. Appreciation of the pound is associated with a falling price in pounds. So essentially, this transaction is denominated in dollars, so there's really no economic exposure, right? The price is the same regardless of the state of the world. So no hedging is needed. Let's consider case 3. Again, same cases for the spot exchange rate. Here, the British price doesn't change at all, right? When you multiply it out, here we get $1,400, $1,500, and $1,600. So the local price is fixed at 1,000 pounds. So what the U.S. firm faces is a contractual cash flow that's denominated in pounds. And this turns out to be the special case of transaction exposure, which we've previously discussed. And this can be hedged using a forward contract, and you can eliminate all of that risk. So let's see how things work out here. Let's assume that the forward exchange rate is $1.50 per pound. In case 1, because the exposure is $1,700, they're going to sell 1,700 forward contracts and receive $1,700 in the future. If the rate falls to $1.40, then the forward contract is going to be worth $1 or 170. That's 1,700 times the difference between the forward rate and the spot rate in the future. If the rate rises to $1.60, then they lose 170. And here you can see here's what the dollar value in these different states are. Okay, these three are the values we had before in the tables, 1372 in state 1, but you also get 170 from your forward contract, so it's 1542. In the second case, where it's 1500, it turns out this is the case where the forward rate is $1.50, right? The forward contract is worth nothing, so the cost is 1500, and here it's 1712, but then you're going to lose 170 right here, right? $1.50 minus $1.60 is negative 10 cents times 1700, so they lose $170, 1542. So you can see the risk is less, but it's not been totally eliminated because of the random nature of these price changes. And let's look at case 3. Here we sell 1,000 of the forward and receive 1,000 in the future. If the rate falls, we receive 100. If the rate rises, we lose 100. It turns out that regardless of what happens, we receive, or the value is 1,500. So this, because it's transactions exposure, turns out to be the case where we can eliminate all of the risk.